In this segment, what we're going to do is we're going to take a look at the question, why study heat transfer? And if you recall, what we said is that heat transfer is basically energy in transit due to a temperature difference. So all of the processes that we're going to be looking at will involve a temperature difference, and we'll be able to hopefully illustrate how heat transfer is taking place in each of those. Now what we're going to do, we're going to take a look at a number of different systems, and I'm just going to list them out, and then we're going to go through and take a look at them and describe them. Okay, so those are the things we're going to look at, and what I hope to be able to show you is that heat transfer exists all around us, and consequently it has significant application into our modern lives. So what we're going to be doing, we're going to be looking at heat transfer within residential buildings. We're going to look at heat transfer within residential electrical systems. We'll take a look at what I call everyday living, places where heat transfer has an impact in our everyday lives. We'll take a look at refrigeration systems that we have in our homes. Lots of heat transfer there. Laptop computers, they generate a lot of heat, they dissipate a lot of heat. Anybody who has a laptop in their lap obviously knows that they generate heat. So we're going to take a look at that. And then finally, we'll conclude by looking at transportation systems. So this is a bit of a gee whiz lecture. The purpose of it is to provide you with a little bit of motivation and background for why we're studying heat transfer. So let's begin. So we're beginning with residential buildings, and here we have a hot water boiler in a house, and we're going to zoom in on the area where the energy is being added. So here what we're looking at, these are flames. We're burning natural gas, and the heat that is generated is used to heat a boiler. Water is circulated using a circulation pump, and then that goes through a manifold system and through pipes that extend throughout the house. Here you can see one of the pipes going through one of the floorboards, and it goes up, and then it goes into hot water radiators. And so through natural convection, which we'll study in this course, that is how the heat is transferred from the liquid through fins into the room, and that's what heats it. Now where does that heat go? Well, eventually it goes out into the atmosphere, and here you can see some homes, and a lot of the heat loss obviously is coming through the windows. That's one of the areas where we have the lowest resistance to heat flow, and consequently that is heat transfer in residential buildings. Another one we're going to take a look at, let's now look at residential electrical systems. And so this begins with the power that is coming to our homes from power plants that could be very, very far away. But what happens is that power is at a high voltage. It needs to be reduced, and there you can see a transformer on a pole. If you have underground lines, yeah, that's another transformer. Again, the transformers get hot. It comes into our homes, into a distribution panel. There you can see the ground fault circuit interrupts are a little hotter. We have a stove clock, a telephone. They're all generating heat, a cable splitter, a power bar, a cable box with your TV, a photo frame. They generate a lot of heat, as you can see on the right. Ground fault circuit interrupt plug on the left, and a dimmer switch on the right. And then these are interior wall plugs and exterior wall plugs. You can see on the exterior we lose heat to the outside. So that's a quick look at electrical systems. Now a lot of those systems are being cooled naturally, and consequently there is no forced convection providing the cooling. But cooling of electronic systems is very, very important, and we will be looking at that throughout this course. The next segment that we're going to look at is what I call everyday living. So let's take a look at that. Now, everyday living, we're going to begin with the biological. A professor that is in shape is a happy professor. This is me on a stair stepper, and you're going to see a 45-minute workout compacted into a short number of seconds. You can see as I go into the workout, you're looking at it every 5 minutes. So watch what happens to my body. I'm getting pretty hot. You can see that I'm sweating a lot, so my body is regulating the temperature by perspiring, and then that provides cooling to my body. And as I go on and on, you can see that my head is getting hotter, as are my hands. There, I'm done. I'm stretching a little bit. And there you can see the byproduct of exercise. I'm very happy. We have hot water systems in our home. So there you can see hot water coming out of the tap. You change it to cold, all of a sudden the water goes black. So actually it's just cold, and with the infrared camera you can see it. This is something that I like to do every day. I do like coffee, I have to admit. So here is an automatic espresso maker, and you can see the hot espresso coming into the cup. Lots of heat transfer in these things if you've ever taken one apart. A number of different boilers. And you take that hot coffee, and here we're pouring hot coffee into cold milk. So the milk is on the bottom, and there you can see the beautiful natural convection cells that are forming. We will study those in this course. They're not as perfect as Rayleigh-Bernard convection cells that we will look at, but nonetheless they are convection cells. And eventually the coffee and milk comes to a uniform temperature, and there is the coffee cup ready to be consumed. So that is heat transfer in everyday living. The next thing that we're going to take a look at are refrigeration systems. Household refrigeration used to be done by bringing in a block of ice, and you'd put it in what they called the ice box. And then through the development of the refrigeration cycle, using different types of working fluids, which I cover in my thermodynamics course, we have the convenience of having refrigeration in our home. So this is something that happened long ago. But anyways, let's take a look at those. Refrigeration systems, we're going to look at two different types. We'll look at what I call a free convection refrigerator and a forced convection refrigerator. So let's begin with the free convection. And so there you can see the compressor at the bottom, and the heat rejection in this cycle is through coils that are on the back of the refrigerator, and those coils are connected to wires that are essentially acting as fins, and then you have natural convective heat transfer. So those coils are hot, and there when you look on the IR camera you can see the compressor is very hot. You have the hot refrigerant going up and then coming through the coils, and that's what rejects heat to the room. Now, more modern refrigerators, they've compacted everything into the bottom, and we use forced convection, so there is a fan in these systems. So there you can see the IR on the left, the compressor is hot, and then the coils are on the right. And there you can see the fan right in the middle, and what it does is it forces air to go over the coils where we're rejecting the heat from the refrigerant, which then becomes part of the cycle for refrigeration. So lots of heat transfer in your refrigerator. The next thing we're going to look at, electronics. A lot of cooling is required in electronics, and so we're going to take a little bit of a history review of laptop computers. So let's take a look at the IR signature of laptops. This is from 1998, a Micron Transport XKE. You can see the thermal signature. Sony with a P3 processor from 99. Another Sony, another P3 from 2001. Another Sony, this one with a Pentium M from 2005. Here's another Sony. This one always operates hot for some reason with an i7, and then here's another Sony that does not operate as hot. So those are Sonys. Here are some Apples. Apple manages the heat in a very different way. It brings it out behind the keyboard, as you can see in these images. So that's a MacBook Pro, and then a MacBook Pro 15 with a Retina display. And you can see where the heat is dissipated. And this is an older Dell, but I like this one, 2002, for the reason that I have a motherboard, and so we can take a look at what's going on the inside. And there I zoom in on the processor, and if you look at the processor, it is attached to a heat dissipation system. There's a heat pipe which then moves over to some fins, and then there's fans on the other side of the fins that result in forced convective heat transfer to remove the heat from the processor. And so that was a heat pipe that you're looking at, and we will be looking at at the basis of heat pipes when we study boiling and condensation in this course, and we'll also be looking at fins. So all of those things we're going to be looking at in this course, and cooling of laptops as we put more and more transistors onto the processors becomes more and more of an issue, and consequently there's tons and tons of heat transfer in any kind of electronic systems, as we could see with the laptops. The final thing we're going to look at is transportation. So transportation, we're going to begin. This is a Chevy pickup truck. You can see the engine is hot, the exhaust pipe is hot. This is looking at the engine, on the inside of the engine with the engine running. That's the radiator hose going to the engine block. And a lot of heat. The only thing that's cool in there is the air conditioning compressor, which is on the top in the middle, as well as the inlet air duct. You can see that that's a little cooler, but everything else is very, very hot, including the alternator. Looking, where does that energy go? Well, it propels the car, and it also goes out through the exhaust. And so there you can see the exhaust pipe. Products of combustion are heat, CO2, and water vapor, as we could see there. These are vehicles in transit, and so here we can see there are different thermal signatures for many different types of vehicles. There you have a big semi-trailer, and it has its exhaust pipes. When you look at the exhaust from the back, sometimes you see dual exhaust manifolds, sometimes you see just a single exhaust manifold with the hotspot on the back of the car. And then these are cars in traffic. So on the left we have stop and go traffic, on the right we have free flow, and you can see in stop and go that the cars are getting hot because they don't have as good of a convective heat transfer as they've been designed for, and that's why they're operating very hot as they drive by and stop and go. Now this is an aircraft. This is a Dash 8 landing in Calgary, and you can see the turboprop engine, a lot of heat there, and then on the left we can see the blade. And touchdown. And then finally, this is another aircraft with a gas turbine engines coming in, and you can see the gas turbine engines are very, very hot. A lot of thermal systems are in there: thermodynamics, fluid mechanics, heat transfer, and consequently that is a very, very important area of keeping the gas turbine blades cool, as we'll see here. This is the blade from a gas turbine engine, and what you're looking at here, this is the leading edge of the gas turbine blade. Looking at it from the end, you can see the cross section, and so it's a very curved shape. The other thing to notice, there is a bit of a bluish white coating, and that would be a coating to protect it from the high temperatures that would be encountered within the exhaust gas stream of the gas turbine engine. And the other thing to notice is that there are a number of ports on the bottom of the blade where it would go in to the engine itself, and compressed air from the compressor would be used and ported through that ducting system, and then it would come out through these small ports. There's some on the leading edge, there's some up on the tip of the blade, some towards the trailing edge, and then even on the tip you can see there are more ports there. Those are used for cooling the blade due to the hot combustion gases, and that is the gas turbine blade. So there we go. You can see a lot of heat transfer exists in systems that we have in our everyday lives, be it transportation, be it things within residential, be it everyday living. So hopefully that provides you with motivation to focus and study on heat transfer throughout this course, under the realization that it is very, very important to our lives. Everyday living, we have enormous amounts of heat transfer in it. And I only focused on some of the things that we encounter daily. There are also industrial processes with enormous amounts of heat transfer, and consequently, but the principles are all the same, and any of the principles that we develop for these systems would apply to industrial systems as well. So I hope you enjoy that. You can come back and watch it if you need more.